Good day, everyone. Today we are talking about section 3.5, linear systems of inequalities. Our target for today is I can graph a system of linear inequalities shading the final solution. So today we are going to graph systems or multiple inequalities. That's pretty much all it is. We're going to be graphing 2, 3, or potentially 4 inequalities on the same graph, and so we're going to be only shading the final answer. So we're going to go through some examples of this, but really it's kind of a review of things we did in section 4. So when it says graph the system, so we're going to graph this first line, y is less than or equal to 3x plus 2. So we're going to go graph 3x plus 2. So we got positive 2. Again, solid dot, slope is 3. And we're going to draw this solid line. I'm just doing these points for my reference. So we're going to draw this solid line here. Now, in section 4, then, we would plug in 0, 0. So we're going to plug in 0, 0. And we get 0 is less than or equal to 2, which is true. Which means we are going to shade the side of the origin. Now, instead of shading it, though, because we're only going to shade our final solution, what we're going to do is we're going to use arrows. So you can use arrows like that. Some people will do arrows like that. You do arrows however you want to indicate where you are going to be shading. I tend to only put them on the ends of the graph because we're going to have another line here, this y is greater than negative x plus 4. We are also going to graph that on the same plane, so I'm only going to put the arrows on the end. All right, so we're going to graph this one. Y is greater than negative x plus 4, so we're going to go to 4. I'm going to do open dots simply because that's what I like to do. But we're going to draw this dashed line for negative x plus 4. And again, putting in 0, 0, we get is 0 greater than 4? No, so we are shading away from the origin. Oh, I got a little curved here. All right, so we're shading there. Now, where the overlap is, so I'm going to come in now, and now that I've done both of my lines, I'm going to come back and add some more arrows so that I know where I can add it. Now, where my arrows are overlapping, that is where we are going to shade. So if I look at it, this section right here is being overlapped. This is what we are going to shade as our final solution. So any point in that region is true for both equations, or sorry, both inequalities. And that's what we're looking for. So we shade the final solution only. So you use the arrows as kind of your work. What some people will do is like super light shading. And when I say light, I mean like barely can see it, and then they will shade their final answer heavier and darker. Please, I beg of you, use pencil and check your work, because if you make a mistake with pencil, you can erase it. With pen, you're going to be coming up to me and go, Mr. A, I made a mistake. Can I get a new graph? All right. Same thing here. So I'll walk you through the process again one more time. So the first one here, y is less than negative 2x minus 3. Perfect. I'm going to graph this one in green. So we're going to go negative 3. Again, open dot. Our slope was negative 2. So we're going to go and do our open dots. So we're going to draw our line. Again, dashed. Plugging in 0, 0. We get 0 is less than negative 3, which is no, so we shade away from the origin. Now, this one's in standard form. Again, as I talked about in section 3.4 when doing the standard form inequalities, if you recognize that 4 goes into 8 and 2 goes into 8, you can use the intercept method where you plug in 0 for x and then solve for y, and then plug in 0 for y and solve for x. Or you can solve it for y and get it to slope intercept form. And if you're going to do that, you would subtract. I'm just going to copy it over here. I'm going to do this in a different color. So you got 4x plus 2y is greater than or equal to 8. You're going to subtract 4x. And then divide everything by 2. And have y is greater than or equal to negative 2x plus 4. Again, we divided by a positive, so the sign would stay the same. So positive 4, 1, 2, 3, 4. Slope was negative 2. And this was a solid line. And again, I can plug in 0 wherever I want. I get is 0 greater than or equal to 8? No, so I'm shading away. All of a sudden I look and go, wait a minute. The green line, the first line is going to the left of the line. The second line is going to the right. Where's the overlap? There isn't one. No overlap means no solution. Okay, it's rare, it does happen, but if I think about it, these lines have the same slope. They're parallel lines. So they're not going to cross each other. And so this is a situation in which they don't overlap, so we would say no solution. This doesn't happen a lot, but I wanted to expose you to it because if it does happen, you know, oh, they don't overlap, that means there's just no solution. It's not a big deal. All right. I would like you to pause the video and try the next one on your own. All right, so the first line I did in green here. So you had negative 2, slope of 3, a solid line. We plugged in 0. We got is 0 less than negative 2? No, so that's why the arrows are going to the right and away from the origin. Again, I did two different methods here. On the left, I did if you did the intercept method where you plug in 0 for x, solve for y, 0 for y, solve for x. I also did the if you just solved it for y equals mx plus b, so subtract the x over and had y is greater than negative x plus 4. That is that red dashed line. Again, we tested 0, 0. You got is 0 greater than 4? No, so that's why you see these black arrows going away from the origin. And then I see where is the region that the arrows are overlapping. In this case, it's kind of this right region here that I've colored in. That would be our final solution. And that's what we're looking for when we're doing this. All right. Now, we can also have the v-graphs with this. So we're going to be reviewing the v-graphs. So our first one here, we have y is less than 2. So we're going to do our simple y is less than 2. So 2 on the y-axis. Put in 0. Is 0 less than 2? Yes. So we know we're going to be shading below that line. And again, when you're doing these v-graphs, if it helps you to identify A, H, and K, so you know your vertex is 1, negative 2. So we're going to go to 1, negative 2. Slope of my sides is 1. So I'm going to draw this. And again, going all the way to the edge of the plane. Slope of the sides is 1. Going all the way to the edge of the plane. And plugging in 0. So then you get 0 is greater than or equal to. And we plug it in and get Absolute value goes 0 minus 1 is negative 1. Absolute value is 1 minus 2 is negative 1. Is 0 greater than negative 1? Yes. And if I look, the origin is inside, so I am shading inside. Now this one's a little trickier to do when I'm doing my overlap, but it is inside of the V below the dashed line. So it is just this little triangle inside here that we are shading. It's not, so we have to be careful and take our time when doing these. Some of them is going to be a big region, some of them it's a smaller region. All right, so this system we have 3 inequalities, which doesn't change anything. We should be able to graph the x is greater than 1, a vertical line, y is less than or equal to negative 2, that horizontal line, and then this v graph. So pause the video and graph each of these 3. All right, so we graphed x is greater than 1. You can see that the blue vertical line here, arrow going to the right because it's greater than. We did so, and then we did y is less than or equal to negative 2. That is my green line. Arrows going down. I graphed the v graph. Y is less than negative absolute value of x plus 2 plus 3. So our vertex was negative 2, positive 3. Again, h is opposite of what appears. A was negative 1, so we graphed that. We put in 0. We got 0 is less than 1, which is true, which the origin is inside, so we are graphing inside the V. So we need to go inside the V, right of the blue, below the green. Okay, so it is this region right below and inside. So this trapezoidal region right here is what we are shading. That is our final answer. Okay, so on these, we need to take our time. We need to double check our work. And it's nothing that's overly complicated. It's just multiple on the same one. All right, our last one. So on this one, we have 4 of them. So we had 3 on the last one, we had 4 on this one. Again, it has to be true for all of them in order to be true. So just like last time, pause the video, go ahead and graph all 4 of these. And if you're not sure where to shade, check back and I will talk about the shading again with you. But pause the video and try graphing each of these on your own. All right, so I did all the graphing. So we got x is less than 2, so you got this vertical dashed line here at 2 on the x-axis, and arrow left. And then we got the purple, y is greater than 2x minus 4, so we graph 2x minus 4 in purple. We put in 0, 0. 0 is greater than negative 4, so we are shading the origin sign, so you see the arrows going to the left or above it. Y is less than 3, so you got this blue horizontal line with the arrows going down. And then because 2 does not divide evenly into 9, I decided to solve this equation for y. So I subtracted 2x, divided by 3, and had y is greater than or equal to negative 2/3 x minus 3. And then I graphed that line, the solid line in red. I put in 0, 0, and I get 0 is greater than or equal to negative 9, which is true, so we shade toward the origin. So our final answer for shading is above the red line. Okay, so it's above the red line, left of the purple, so we're talking this region here, below the blue and left of green. So I'm going to border the region, and then I'm going to color it in. Kind of an odd shaped region here, but the more stuff you add to it, so like in this one we had 4 lines, the more odd shapes you get. You could have a 5th one. Maybe we had another x equals Like maybe we had x is greater than -3 and it kind of put a left boundary on it. Either way, when you are doing this, you need to take your time and check your work. If you have questions, make sure you are asking in class. Otherwise, have a great day, everyone.